Good evening to all you guys, and I hope you guys are enjoying watching video notes again. I want to remind you of this. This is incredibly important. I have not checked your Chapter 4 vocab packets, but I'm soon to do so. So you need to make sure you have the Isosceles Triangle Theorem 4.3, its corollary and its converse, along with Theorem 4.5, all written in your vocabulary packet. So you should have already written these theorems down. You should have already had the parts, so I just want to kind of show you how to use them. Okay? First of all, we're going to start with isosceles triangles. I want to show you how you name the parts of these triangles. So let me first draw an isosceles triangle. Don't forget, an isosceles triangle is a triangle that has two equal sides. And then how do you name the parts? Well, the two equal sides are called the legs. So this is a leg, and this is also a leg. The bottom of the triangle, the bottom of this triangle right here, this is called the base of the triangle. And this angle at the very, very top, this angle is called the vertex angle. Or in other words, the vertex is right here. So we have the vertex of an isosceles triangle at the very top, the peak, two legs, the two legs are equal, and then the base of the isosceles triangle. Alright, let's talk about an equilateral triangle. Remember, equilateral means all three sides of the triangle are equal. And in the equilateral triangle, all three sides are simply called legs. So this is a leg, this is a leg, this is also a leg. So you can rotate this triangle so any of them, they're all the same, so they're all legs of the triangle. Okay, so let's talk about these theorems and kind of review some of the rules of just isosceles triangles. So we're going to talk about isosceles triangles. Just isosceles. And let's start with the most important rule. As soon as you see a triangle with two sides of the triangle marked equal, you know immediately it's an isosceles triangle. Well, the very first theorem tells you that if the two legs are equal, if these are equal, then automatically you can say the angles are equal. So if the two legs are equal, then the angles are equal. I call this base angles of an isosceles triangle are congruent. These are called the base angles because they're angles attached to the base of the triangle. So base angles of an isosceles triangle are congruent. If you flip it around, if you have a triangle and you're given these two angles are congruent, then the converse is true. If these two angles are congruent, then this side and this side are also congruent, making this an isosceles triangle. That's called the converse. So these two almost seem the same. The difference is if you're given the two sides, then these two angles are equal. If you're given the two angles are equal, then the two sides are equal. So base angles of an isosceles triangle are congruent, and if the base angles of a triangle are congruent, then its isosceles would be the converse of the theorem. Alright, last rule of isosceles triangle. That's a terrible picture. I'm going to redraw that. Last rule of an isosceles triangle. Much better. If you have an isosceles triangle, and starting at the vertex angle, right here, vertex, if you draw the bisector of the vertex angle, so this is my vertex angle, if I bisect it, remember bisect means cut in half. So this angle just got cut in half, and I will know it's been cut in half because these marks will be the same. Well, if you have the bisector of the vertex angle, not only are these angles marked the same, two things are true. It's perpendicular to the base, so automatically I know these are 90-degree angles, and it bisects the base as well. So automatically I know these sides are equal. So that's a beautiful rule because you get two things. The bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. This is the conclusion. The perpendicular bisector of the base. So you have right angles, that's the perpendicular part, and then the bottom gets bisected. So incredible rules going on with isosceles triangle. Okay, let's talk about an equilateral triangle. We're going to use this rule, but we're going to push it one step further with equilateral triangles. So here's the rule. Don't forget, if you have these two sides equal, then I know the angles opposite those sides are equal. But if I have three sides equal, then by default, this angle is equal, this angle is equal, and this angle is equal. So an equilateral triangle is also equiangular. And don't forget, all these angles are 60 degrees. And you can go backwards. Go backwards if you know that all three angles are equal. Then by default, you can mark this side equal, this side equal, and this side equal. So if all three angles are equal, all three sides are equal. It's kind of the isosceles triangle, but pushed one step further for equilaterals. Okay, let's apply these rules and use them in examples. Okay, first of all, problem number one. Can you explain to me why triangle ABC is isosceles? And I don't have any marks except for some arc marks. And I'm looking at these arc marks and I'm like, okay, why in the world is this triangle isosceles? What would make it so? Well, this is the reason why. This mark and this mark, incredibly important. That means these lines are parallel. And don't forget about our alternate interior angle theorem. Our alternate interior angle theorem tells us if we have parallel lines, which we do, then alternate interior angles are congruent. So because this was marked with one arc mark, this is also marked with one arc mark. So why is this triangle congruent? Because the base angles are congruent, making automatically these sides congruent. It's the converse of the isosceles triangle theorem. So use alternate interior angles and the converse of the isosceles triangle theorem. That's how you know. Okay, let's apply it with some algebra. It says, suppose that angle L is actually equal to y. So this is a y. Find the values of x and y. You're like, man, that's interesting. Okay, if this angle is a y, and I notice these two sides are equal, that means by the isosceles triangle theorem, these two angles must be equal. That means this angle is also a y. I also know from the theorem 4.5, it says if the vertex angle of an isosceles triangle is bisected. Well, how do I know it's bisected? Because these arc marks are telling me that these are the same. That means that this line, MO, is also the perpendicular bisector of LN. So MO is the perpendicular bisector of ln. That comes from Theorem 4.5. Well, this is very helpful because I now know what the value of x is. X has to be 90 degrees. Okay, let's go back to this y. I know this is y, and so this also has to be y. And the question is, how do I know what these angles are? Well, I'm going to use the fact that the triangle sum theorem tells me all the angles have to equal 180. I frankly don't care which triangle you use, but I choose to use triangle LMN. So I know that this y at L, I know angle L plus angle N plus angle LMN has to equal 180. So what I really know is that this y plus this y plus 2 of those y's for this angle has to equal 180. And solving this, I get 4y equals 180 divided by 4, y is equal to 45 degrees. So my x is 90 degrees and my y is 45 degrees. Alright, that takes care of that example. Let's flip our papers around and do some more problems. We're going to use this diagram for exercises 1 through 3, and we're going to replace some numbers in here. Right away I noticed an amazing thing about this diagram is that I have an isosceles triangle as indicated by the 2 congruent legs. So let's take a look what we're going to do with this. Very first problem, number 1, says if angle BAC equals 38. So angle BAC, this great big angle, is 38 degrees. It says find angle C. Well, I know that these two angles must be equal. So I know that this, let's call this x, let's call this one x as well. And the triangle sum theorem says all 3 angles must equal 180 degrees. So I have x plus 38 must equal 180 degrees. 2x plus 38 must equal 180 degrees. I'm going to subtract 38 from both sides. So I take my calculator and I'm going to go 180 to take away 38. 180 take away 38 is 142. I'm going to divide it by 2 and I get x equals 71. So for the very first problem, the measure of angle C equals 71. And I'm done with this problem. Okay, let's apply it to a different problem. Number 2, we have to erase these marks in our picture or just redraw the picture. This problem says if the measure of angle BAM equals the measure of angle CAM, which equals 23. So this angle is equal to this angle, and they're both equal to 23. This is important because right away I can use Theorem 3.5, which says that the bisector, I know this is bisected because these are equal, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So I can add right angles at that point. The instructions say find the measure of angle BMA. BMA is this angle. Without doing hardly any work, I know the measure of angle BMA must equal 90 degrees. Okay, number 3. Erase my marks. You guys can redraw your picture if you want, or erase your marks. It says this, if the measure of angle B is 3x, now don't forget, this angle and this angle are the same. So this angle is 3x, and the measure of angle BAC, the entire angle, is 2x minus 20. find x. If this angle is 3x, this angle over here must be 3x. And we're going to use the triangle sum theorem again. All three angles must equal 180 degrees. Combining your like terms, 3 plus 3 is 6, 7, 8x minus 20 equals 180. Add 20 to both sides. 8x equals 200. Dividing by 8, x is equal to 200 divided by 8 is equal to 25 degrees. And we found the value of x. Okay, a little more complicated pictures. Let me clear this ink. Find the values of x and y. X and y. Now I've got, looks like half of a hexagon in this picture, but I notice these congruent angles. And so I know for a fact that this side must be equal to this side. This side, and the same with this triangle. This side and this side must be equal. So what I really have is an equilateral triangle, because all these angles, if this is 60, these angles all must be 60. And so I have equilateral triangles here. Every one of these angles are 60 degrees. All of them. So this is 60, 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 and I've just now found the value of x. So I know x is 60 degrees. I also know that these are all equilateral triangles. Equilateral. And so this side has to equal this side. And if two of these sides are equal to 18, these are all equal. This must be a y, and this must be a y. So 2y must equal 18, making y equal to 9. And I'm done with my problem. Okay, last problem. ABCDEF is a regular hexagon. Regular means all the sides are equal and all the angles are equal. All the sides are equal and all the angles are equal. What I would like for you to do is find out what all the interior angles of a regular hexagon are equal to. 6 take away 2 is 4 times 180. The answer is 720 degrees. I'm going to divide this equally amongst 6 angles. And if I do that, each interior angle, one interior angle, is equal to 120 degrees. So I know these angles are 120 degrees. The problem says find the measure of angle BAC. So take a look what we have here. This angle right here is 120 degrees. This is 120, this is 120, this is 120. But I want you to focus on this triangle. I'm going to redraw it so it's a little bit bigger. This is A, B, C. That's 120. And don't forget, these sides are equal. This is an isosceles triangle. Therefore, this angle is equal to this angle. I don't know what it is, but I can use algebra to find out. All the angles must equal all the angles must equal 180. So I'm going to add them up and set them equal to 180 degrees. Subtracting 120, 2x is equal to 60, and divided by 2, x is equal to 30 degrees. So therefore, the measure of angle BAC equals 30 degrees. And I'm done with my problem. Okay, I hope you're ready to do homework tomorrow in class. Lots of algebra. Have your calculators with you if you want to bring your own. And you guys have a great night. Bye.